App service plans in Azure provide the underlying infrastructure for hosting web apps, RESTful APIs, and mobile backends. They define the region, data center of the physical server, the pricing tier, and the amount of resources, CPU, memory, and storage allocated to your apps. Understanding how to configure and manage these plans is crucial for optimizing performance and cost. Scaling is essential for maintaining application performance and availability. As user demand fluctuates, scaling ensures that your app can handle the load without degradation in performance. It also helps in cost management by allocating resources dynamically based on actual usage, preventing over-provisioning and under-provisioning. Azure App Service Plans support two types of scaling: vertical and horizontal. Vertical scaling involves increasing the size of the instance, e.g., moving from a standard to a premium tier, while horizontal scaling involves adding more instances of the same size. Each type has its use cases and benefits, which we'll explore in detail. Vertical scaling, or scaling up, involves upgrading to a higher pricing tier to get more CPU, memory, and storage. This is useful for applications that require more powerful resources but don't necessarily need to handle more concurrent users. Vertical scaling is straightforward, but has limitations in terms of the maximum resources available in the highest tier. Horizontal scaling, or scaling out, involves adding more instances of your app to distribute the load. This is ideal for applications with fluctuating user demand, as it allows you to handle more concurrent users. Horizontal scaling can be automated using Azure's Autoscale feature, which adjusts the number of instances based on predefined metrics like CPU usage or request count. Azure's Autoscale feature allows you to define rules for scaling out and scaling in based on metrics such as CPU usage, memory usage, and HTTP request count. You can set thresholds for when to add or remove instances, ensuring that your app always has the right amount of resources. Autoscale can be configured through the Azure portal, CLI, or ARM templates. Manual scaling allows you to adjust the number of instances or change the pricing tier manually through the Azure portal. This gives you full control over the scaling process, but requires constant monitoring and intervention. Manual scaling is useful for predictable workloads where you can anticipate changes in demand. To make the most of scaling, follow best practices such as monitoring performance metrics, setting appropriate autoscale rules, and testing your scaling configurations. Regularly review your scaling settings to ensure they align with your application's needs and cost constraints. Also, consider using Azure Advisor for recommendations on optimizing your scaling strategy. Effective scaling requires continuous monitoring of your app's performance. Azure provides various tools like Application Insights and Azure Monitor to track metrics and set up alerts. These tools help you identify when your app is under or over-provisioned, allowing you to adjust your scaling settings accordingly. Alerts can be configured to notify you of any issues in real time. Scaling directly impacts your Azure costs. While scaling out can improve performance, it also increases your expenses. Use Azure Cost Management and Billing to track your spending and optimize your scaling strategy. Set budgets and alerts to avoid unexpected costs, and regularly review your usage patterns to make informed decisions about scaling. Consider an e-commerce app that experiences high traffic during holiday seasons. By implementing autoscale rules based on HTTP request count and CPU usage, the app can automatically scale out to handle the increased load and scale in during off-peak times. This ensures optimal performance and cost efficiency, providing a seamless shopping experience for users. Common pitfalls in scaling include setting inappropriate thresholds for autoscale rules, neglecting to monitor performance metrics, and failing to test scaling configurations. Avoid these mistakes by thoroughly understanding your app's requirements, regularly reviewing your scaling settings, and using Azure's monitoring tools to stay informed about your app's performance. The future of scaling in cloud computing involves more intelligent and automated solutions. Machine learning algorithms can predict usage patterns and adjust scaling settings proactively. Azure is continually evolving its autoscale features to incorporate these advancements, making it easier for administrators to manage resources efficiently. Stay updated with Azure's latest features to leverage these innovations. Configuring scaling for an app service plan is a critical aspect of managing Azure Compute resources. By understanding the different types of scaling, setting up auto-scale rules, and following best practices, you can ensure that your applications are both performant and cost-effective. Continuous monitoring and staying updated with Azure's latest features will help you optimize your scaling strategy over time.